So good morning. Good morning, everyone. So it's good to have you here this morning. You can all see my screen, right? Okay. So what we're discussing this morning, it's going to be AWS hands-on. We start from scratch. We build it, and we are going to secure it with the basic AWS security measures that we have, and then we'll try out some different scenarios across the traffic flow from outside to the AWS cloud, and also from inside to outside as well, as vice versa. So let's get started. So this is just about me. I think everybody knows this already. So let me just get to the deal of so what we're discussing today is going to be about AWS billing. We create VPC, the private subnets, the Internet Gateway NAT Gateway, the routing, and also creating a jump service, which is also like a Bastion Host, and also ensuring security group and network ACL. So we're going to start all this. Is going to be from on the GUI part, as we all agreed last week. And one of the first important things is for you to create a billing alarm. It's very, very important. One of the principles of architecture is you must be able to have a kind of a cost optimization principle when you're creating an AWS account or deploying on AWS, because you can over provision or spend more than what you budget for. So one of the important things to do is create a billing alarm, so that at the end of the day you won't get more than you've actually allocated for. So let's go back to our use case, the same company. So these are the tasks you have to do. So you set up the AWS billing alarm, you plan the subnets. I think we did that last week. Privacy based on the closest region, and the 3 VPC. And the essence of the Bastion Host, I'm going to explain it further in the further session. So this is the same subnet. I think all of us understand it to this point. This VPC side range. Can I have some reactions so that we will know if I need to just brush over it again? Hello, can anyone hear me?
I can hear you.
Okay, so what I'm saying is this VPC, this side range, I think we all understand it, right?
Yes.
Okay, all right, this stuff. So we are creating 3 VPC, but starting with one, so which is the web app VPC. And I explained that the CIDR range, which is the main CIDR range, is going to be /16. And the explanation which I did last week was the system will have about 65,000 IP. So it's better to have more than to have less. So one of the important things to factor in when you're creating your AWS is the subnet mapping, your CIDR block. You must make sure you're planning it in a way that you don't just get exhausted easily. So that's why it's advisable to start with /16, /20, slash all those /20, /16. I think I explained it last time that can just watch the previous video. Like it's more of like a binary IP address and all of that. So let's, because of time. So what we'll be doing majorly is the web app VPC. CIDR block is 10.200.00/16. So this /16 means that the first octet is filled, the second one is filled. So what the possible values we can have will be located in the third octet and the fourth octet. So that's what /16 means. So each octet, like what I'm talking about octet is every value before the dot. Each octet has its own value. So each octet is an 8 bits rather. So that's why they called an IP address a 4 bytes. 1 byte is equals to 8 bits. So each octet is 8 bits. converting to base 2, you're having 255 and all of that. So what I'm saying in a nutshell is that the first octet and the second octet is filled up. That's why you have 16 here. So if the first 3 octet is filled up, you are going to have 24 here. So any values that will be changing or incrementing will be the last one. So that's what it all means with its side range. And the region we'll be using is the region US East 1. This same thing here as well. We have this guy, the subnet planning. So I think last week we explained that, okay, let's have our private subnets in even number. So the third update will be even. So which shows that, okay, when we are planning, we can easily identify that, okay, this guy is a private subnet, while this other guy is also a public subnet. So that's that on the planning. So this is what we want to achieve today. So the VPC is a region-based service. So that's where our VPC US is 1. So we're going to now break them, the subnet down into availability zones. We have availability zones A and availability zone B. So in each of the availability zone, we'll be having a private and public subnet in each of the zone. I get to my point. So this is what we actually want to achieve today. So before we start, let me just let's create a billing alarm. So this is my AWS console. This is my AWS console, and from what you can see here, I'm not. You can see that I'm an IAM user. I'm an IAM user. Can you see? I'm an IAM user. And this IAM user doesn't have access to the billing account. You know, I explained last week that in AWS, you have 2 accounts. You have the root account and you have the IAM account. The root account is the one that creates the account. That's the super admin. So the email you use to create the root account is going to be your super admin. So as a root account, you have access to the billing, to everything about your accounts. But for me, which is an IAM user means identity and access management user. Just someone like your developer, your database admin, your power user, your network engineer, your cloud administrator. Those kind of access are IAM access. So those guys cannot have access to your billing by default. So if I click on billing and cost management now, you would see what I'm going to get. Can you see what I'm saying? You can see that it's saying data unavailable, access denied, all of that. And the reason because is that I'm just an IAM account user. You can see I don't have any data for this guy, for myself. So this shows that you might come up in interview, they must ask you like, okay, why does an IAM user doesn't have access to your billing account? So you'll be able to explain to them the reason behind it and all of that. So for us to have an admin access to an IAM user, like the billing for an IAM user, you need to log into the root account. You need to log into the root account to enable the access. So now let's do that. So the first thing is that I need to sign out. So I'm going to sign in back. So now I'm signing in. So this is how an IAM signing. IAM signing is going to be your account ID, your username, and your password. For example, your company is something, maybe money pay. So that's your account ID. Your username is daily.adekunle. Your password, put it there. So you sign in. That's how an IAM user sign in. But for a root account, you need to sign in with your root user email. So you need to click on the sign in using root user email. So you can see there are 2 options here. You can sign in with root user or IAM user. So signing in with the root user. So let me just put in my root user username. Let's continue. So that's my root username. So I'm putting my password. So I'm putting my MFA. You know, I explained the MFA last week. That MFA is like a multi-factor authentication. So I'm using Google Authenticator. It's just like another layer after putting your username and password, another layer to just guide you, just to avoid uh, authentication. How would I put it? Just to ensure that your authentication is highly secured in a nutshell. So it's going to be a 6-digit value. Oh, so what's happening? So let me go back. I think my username and something. Let me just. Um, I still remember my username and password like this. So let me get the username and password, and trying to get the username. Okay, I think I have it here. But for companies use identity signing. So there's a way you can integrate your AD to AWS so that you can use like a federated accounts to log in, not all this kind of signing. Do you understand? So we might require an AD to do that, but maybe in our future sections we can just simulate something like that. Yes. So finally, I'm in my root user account. So if you click on this is my ID, you will see something different here. You can see this is you won't see IAM user again. Before, in the IAM user stage, you're going to see IAM user and all of that. But you can see that just your account ID and all of that. So you need to click on accounts. So on your account, there is a way you can grant the access to. So this is what you are. So you all have is in two ways. I can say, okay, let me just do my billing alarm right from here. So maybe I don't want my user to have that kind of privilege. So all I need to do is, okay, I'll just come to budgets. Budget. So let me create a budget for myself. I'm doing it from the root accounts. So using it, these are the templates we have. So you can choose any budget you want. Maybe you want to a zero spend budget. You don't want to spend anything at all. You can set that. Or maybe you want to like spend, but you have a threshold of what you want to spend. For example, I can say, okay, let me just create a monthly cost budget. Okay. What is my monthly cost budget I'm looking to? Maybe I'm looking like $10. I'll just put my $10 there. And okay, what's the email? I think I need to get a notification. Maybe when I'm closing towards this budget, it's going to send a notification for me. Okay, Sulaiman, you're getting closer to your budget, and you need to do something about it. Maybe I need to delete some instance and all of that. So I just say, okay, here's a continue at gmail.com. So the number of recipients you can use here is 10. So you can just use a comma, put another username, maybe your admin, your finance team, your compliance team, and all of that can just be the mail recipient. So when you are closer to this budget, it's going to send you a mail. Okay, this and 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 this. This is what you have. So you'll be notified. This is actually what's going to happen. So there's a way you'll be notified. Okay, when it reaches 85%, 100%, and all of that. So this is how the budgets actually work. So you can create based on what you want. Even you can even create a customized one. Maybe you want a customized one you want to do by yourself. You can just create it by yourself, and you put alerts, you put options and all of that. So just because of time and because of we still have a lot of things to do. So it's something you can just go through by yourself and check which option you want to. So the customized one, you can create a large, can create when it reaches 80%, it should pause you. Or when it reaches 70%, it's going to send you an email and all of that. So it's something you can just play with at your time. So let me just do. So people using free tier, I advise you to use the zero spend. If you're using a free tier account and the card you attach, you don't have funds inside the card, so you can just use zero spend. But I think I have some credit here, some credit here. So let me just put like $20 here, 20. So put my mail back again. So I'm just trying to show you the options that you can use at gmail.com. So yeah, I think my mail is not correct. So good. So it's going to create the alarm for me. Yeah. So this is what it's going to create for me. So this is how the budget comes in. So that is how you plan the budgets. So in the customized part, you would see different stage. Okay, maybe going to reach 50%, it's going to pause you, maybe reaching 80%, it should pause you, and all of that. You see it there. So root account is a super admin. You have access to everything. You have access to what you've been using before. Your overview, you have a lot of things to do. Yeah. So if this is all you want to do from your root account, so maybe you don't want you actually want to give someone access to your billing, so you can just go to the IAM and give that person the billing access. Just update the IAM user with the billing permission to the person account. So let me just try to go to this guy. Can you hear me? Someone is talking there. Can you say something? So another thing to point in is that in AWS, we have global service, we have regional service. Global service are services that are available throughout. You can see something here, you see something global. I think somebody should have asked me, why are you saying global here? Why are you not saying North Virginia or US East 1 or some of that? So the reason is that on AWS Cloud, some services are global. Irrespective of the region you only have them constant. You don't change them by region, they are defaults. And the example of them is your IAM. Your IAM is a global service. It's not based on region. Do you understand? So once you have it, you have it. The second one there is Route 53. Route 53 is I think I've explained it earlier before, is your DNS mapping in terms of how you resolve your domain names. For example, www.akindele.com, www.shopify.com. There's an IP address at the back of that guy. But how are you going to, you can't cram IP address, you need to get the host name, you need to get the URL, the domain name. So the resolver, like the DNS that is doing that we have one on AWS, which is the Route 53. So it's a global service, it's not per region. So aside from that, we have the regional service, VPC. We have S3 buckets. We have a lot of that. They are regional service. Even AMI, Amazon Machine Image, your image template, they are regional service. That's why you can see that the last Terraform that we did, the AMI for US East 1 is different from the AMI for EU West 1. So those guys are regional service. They are different. But the two commons, which are the global ones, is the IAM and also the Route 53. So because of time, I think I have two administrator here. So I have administrator. Okay, so what I need to do is just, okay, let me go to the permission. And the next thing I'll just do is assigned billing. So just say add permission, attach policy. Okay, let me say billing. So billing conductor. So billing conductor full access. So maybe I want to give the administrator the billing, or I just want to, for example, there's some finance team that needs, okay, you just want the billing read only. Just want to say, okay, what have you consumed in a month? What have you done? So, but if billing conductor full access is to be able to make changes, to make budget planning and all of that. But it depends. That's why I said the principle of the least privilege comes in. You give people access based on what they need to do. So I can just give the administrator this access and attach policy. So automatically, once I've attached the policy to this guy, you would see that my user, which is my name,
Sorry.
Sulaiman.olubiyi, it's going to inherit that policy. That's why I think group is the best. If I think we have some system admin here that works very well on AD. So once you put people in a group, so once you just attach policy to the group, automatically the users inherit that particular group, that particular policy. So I think that's that on that. So I think I've given this guy the permission to the billing, based that the guy was not a root account. It's just like an IAM account. So this is how you create billing, and this is how you assign access to people. So let me log out, and let's continue our work. So I'm signing in. So let me sign in again. If I'm signing in, so I'm signing in as a user, as an IAM user. You can see that the difference is clear. Signing in as a root, you only have your email and your password. But signing it as an IAM user, you have your account ID, you have your IAM username, and you have your password. So all I'll just put to is just to put my account ID. Some organization, they put this account ID is an alias. There's a number at the back of it, but there's a way you will change it. But don't worry
I
about
have a
that one. That
question.
one is okay. You have a question. Okay, you can continue.
Yes. My question is that instead of signing out,
Okay.
is it not possible to just type IAM on the console? Then it gives us, then we can switch back to IAM instead of signing out.
Yes. You can do that as well. That's a very good
Okay.
suggestion. Also, you can switch role rightly from the root account. Yes, you can do that. It's possible. So you
Okay.
can actually switch role
All right.
from the IAM accounts. And another thing is that if you work with an organization, there is something they call AWS organization. In AWS organization, you can even switch roles within an account. So from one account, you don't need to log out again. You just switch role directly from one one IAM session to another IAM session. Okay, I hope I answered the questions right.
Yes.
668. Okay, so let's get in. MFA is very important. Don't make the mistake of not using MFA. It's very, very important. So now let's get to our work. I don't know why this thing is loading. It's taking a lot to load. So let's go to VPC. VPC. Let's get started. So as I've explained earlier, I've said that VPC is an isolated networking environment that is designed for you by AWS. And there is something they call shared responsibility model. There is security in the cloud, and there is security of the cloud. The security in the cloud is your own responsibility, but the responsibility of the cloud is AWS responsibility. Let me break it down. Let me use that estate as well to break it down further. In the estate, the responsibility of the estate infrastructure, maybe you pay service fee so that they must give you, irrespective, you have to have light 24/7. Those are the responsibility of the estate, which is the responsibility of the cloud. So your infrastructure, your infrastructure, which is the fundamental infrastructure, AWS is the one in charge. But the security in the cloud, which means the security of your data, automatically something relating to the security of your house, maybe your house key, your house closing your house window, or something like that, something personal to your house, is your own responsibility. It's not the estate responsibility. But making sure that you have a very good road inside the estate, you have all of that. That's it. That's for your estate manager, which is AWS. But inside your room, the security there is your own responsibility. So that's why I'm saying that the security of VPC is your own responsibility, because it's just like your own small bungalow in a very big house, in a very big estate. So the responsibility of your VPC is your own responsibility, is attached directly to you. But making sure your VPC is highly available, making sure that when you want to create internet gateway, you can create it. When you want to spin up a VPC, you can create that. Those ones are AWS responsibility. If you're planning to write AWS exams, those are like some tips, especially if you're writing maybe solutions architect or security or some of that. So those questions comes in very well. So the security of your VPC is your responsibility. You must be able to secure your VPC. And this you are, because it's an isolated, virtualized environment for you. It's for you alone. Nobody is taking it with you. You are the owner. So you must be able to plan your security in and out your VPC. So, and I will explain where is your own role coming in and what's the role of AWS. What service can you access? What service can't you access? What's your, like, I will explain the whole scope behind this scenario. So in this, if you create an AWS account, by default, AWS give you a VPC by default. This is the VPC that you see here. And the subnet there is 172.31.31.0.0/16. If I click on this guy, let me click on this guy. Let me click on the CIDR range. This is what I'm saying. You can see that this is CIDR range, IPv4. So one of the best things today is that I'll just come here. You just call it default VPC. Default VPC. And you save. So this has shown you that, okay, you have a clarity. Okay, this is my default VPC. You won't be able to have any mismatch. Another thing is that you notice your VPC ID. Everything in AWS comes with ID. Your subnet ID, your VPC ID, just like your ID card. When you are in school, they give you a matric number. So some lecturers will say that, okay, well, I don't want your name on your script, just give me your matric number. So that's same thing like your ID. So ID is just something to look up for you instead of using your name. So and there's something we call OOP, Object Orientation Programming. So if you are writing a program or you are doing some kind of programming, what should be your reference ID is going to be all this ID. The last session we had with Terraform, you can see that we are referencing some ID, and all of that in our code. So I think everything is getting real up now. So let's continue. So this is the default VPC. And default VPC, it has its own route table. I explained route table last time. And I said in a VPC is breaking down into subnets. You need subnets. AWS is going to take 4 out of it. AWS will take 0.0, 0.1, 0.2, 0.3, and 0.4. It's going to take the first 4 IP and the broadcast. So the first one is the gateway. The second one is reserved, which is your DHCP server for that VPC. And the third one is just reserve it. So if AWS wants to start assigning new IP. Yeah.
Yeah, I think the first one is the network ID, the .0.
Yes, it's going to be network ID.
Yeah.
So the network ID is, I think on the one of the slides in our last session. I'm just trying to do a recap. So the first one is the network ID. Second one is your DHCP server IP for that subnet. The third one is reserved by AWS. And the last one is your broadcast address. That's the last one. But that one is just for educational purpose. Now let's go to the real deal today. So if you want to create a VPC, all you just do is to click here. You can do it in 2 ways. You can just come here. This is your VPC dashboard. Just come here, create on VPC. So you can create VPC only, and you can do VPC and more. I get my point. VPC and more is going to create a lot of things for you. VPC and more is going to create a lot of things for you. You can see VPC and more. We create VPC. It's going to create subnet for us. It's going to create route table. It's going to create Internet Gateway. I think that's all. So they've actually made it simpler. Maybe like 5 years ago, it's not like this. They've actually upgraded. But you can still do a VPC only. It depends on you. But I don't know which one should we go for. Okay, should we go for this one or should we go for
VPC
VPC and
only.
more? Okay, all right. I think
Let's
that's
go
very
for the
okay.
learning scope. For the
So
purpose
now,
of
okay,
learning.
let's go through VPC only. So VPC only, we'll start the VPC and I will start explaining each of those resources how is attached to it. So now this one of our criteria is that okay, we are creating web app VPC. So let's call it web app VPC. Don't bother about my naming convention, but just make sure your naming convention speaks to what you understand. Make sure your naming convention speaks to what you understand. So we are doing an IPv4 CIDR. So and the IP something is 172 dot, it's not 10.200.0.0.0/16. So there is nothing to cram there. You can see that your CIDR block address must be between 16 and 28. So everything is, the information is there for you. No, there is no stress at all. So this is if you are using IPv6, that's there's an option to allocate IPv6, but we're not going there now. So the tenancy, the EC2 instance configuration of AWS. AWS is a way you can have a tenant. Like AWS is going to give you like a dedicated tenant for them, like a rack, like an environment, a dedicated environment for you. So those are types of tenants in AWS, but we are just trying it out here by ourselves. So we use the default one, which is the default one. So let's create the VPC. That's all. So maybe you want to tag, maybe the environment is production, the environment is production, maybe just different tag, just something that you'll be able to get more information about this VPC. Let's put it there. So let's create VPC. There's a way you can preview code. Preview code is maybe the code in AWS CLI. I think we've been saying it before, AWS CLI. So once you create a VPC, it's already done. And these are all your resources associated to it. So this is your VPC. This is your VPC ID. DNS resolution is enabled. I will explain that one later. This is your subnet ID. This is your DHCP option sets. So this DHCP option sets, we're going to understand it better when we start resolving URL domain names inside your VPC. Maybe you have a scenario whereby you will need to resolve a particular URL of maybe an S3 endpoint that you attach to your VPC and you want to resolve it locally from your network. So something like that. So you need to be aware of DHCP option set. But let's still limit our class to what we want to achieve today so that we won't really digress. So you have the main route table. I always advise that you just delete the main route table. You can plan your route table by yourself. So what this guy have? He has the CIDR. Flow logs is a kind of a resource that gives us the log. We have the top parameters: the source IP, destination IP, source ports, destination ports, accept or deny, things like that. Okay, this TCP, is it TCP port 80 or something? So the logs will show the movement of the traffic flow of all those guys. Everything will be on the flow logs. Web app, these are the tags. Integration, we've not done any integration for now. Everything is still as fresh as it is. So we've added VPC. Interesting. So I think we've done one of it. So the next thing is to create the subnets. So just click on the subnets. You can see these are the default subnets, because one of the things you'll be able to check them is just default subnet are associated to your what? To your VPC, default VPC. Assuming you didn't put this name there is no how you'll be able to recognize it very well. But you can see that you have I think it's about 6 subnets for this VPC. So in our own, we are just creating two subnets, four subnets, two in public subnet, two in private subnet. So let's start. Create. So you need to create. You need to show the VPC you want. This is the associated CIDR range. Your subnet web app or private. I don't know. Naming is part of your own discretion, but you must ensure that it follows what you can actually remember. So web app, private one, or private subnets, or private one, private two, or any way you want, or you can put private
Sorry,
A. Okay,
sorry.
you have a question?
Yes, did you click one of the subnets or you just went to click on
No.
subnets, create subnets?
Yeah, you just create subnets. That's what you click on.
Okay.
So web app private A. You know, the implementation is that we need to have two private subnets and two public subnets. Do you understand? So let's say web app private A. Preference, maybe you want to put it in US East 1A. Are you getting? So this is the VPC CIDR block. So now let's choose the CIDR range for our subnet. And based on what we have, let's go back to our slide. On our slide, we have this is what we have on our slide. So this is that's why I said planning the subnet will be really helpful for you, so that you won't start guessing. You have a very cool documentation to follow. So you can see that the private subnet, we have it here already. So we have 2 and .4. So all you just to do is just to create them over here. So let me just come here, 10.200.2.0/24. Are we good? So this is just like an application bar just to include. Yeah, I can hear you.
Yeah. Sorry. So some people might not understand private and the public subnet, right?
Yeah, I
So
will still go there. I'll
okay.
still go there. But I think we even explained in the last class. So because of time, I actually don't want this session to be more than an hour session. So that's why I'm just trying to cut it off. Because the last class we had, we've explained the private and the public subnet part of the thing. But
Okay.
I'll still try and take my just to explain it further. So now let me come back here. The reason why just like a very brief something to go back is private subnet, public subnet. It's not that these guys they are all subnet initially, but the only thing that differentiates them is the route table where they are and how you actually design it in your network. It's not like they are having a public IP. So if you are coming from a networking background, you'll be thinking, okay, public subnet is all this public IP that you get from Afrinic or you get from iPartners and all of that. No, this private or public subnet is based on your design, is based on your route table. And what private subnet means that, okay, the servers, the resources in this subnet, they cannot have access to internet. Something like your database, something like your Kafka, something that you don't want to expose to the internet. So that's things that you put on your private subnet. You can't just expose your database to the internet. So those resources are what you put in your private subnet. And to ensure high availability, that's why we're doing the private subnet 1, private subnet 2, just for high availability design. The public subnet is the subnet where you're going to have your servers, your web servers, your Nginx, your application servers, and all of that. So that's the subnet that you can access it from outside, people can access it and all of that. But you can't want any random person just to be able to access your database from outside. So that's why you put them in your private subnet. But your public subnet is something you want people to see. That's where you have your application servers. That's why you have your Nginx, your Apache, maybe your Node.js application or your Python application where it's running, so that you can easily expose it to the internet. That's why it's called public subnets and private subnet. So basically, it's not like, okay, this guy public subnet has a public IP or anything. No, no. It's just like the subnets from your VPC CIDR range that you've designed. Those kind of subnets, okay, these ones are for my web servers, while these ones are for my database. Or basically, these ones are servers I want to be able to reach from the internet. These ones are the ones I don't want internet access on them. Just something secure, something local to me. So how does it have access to internet? How is the routing going? We're going to explain that going forward. So let's go back to our VPC. So this is the CIDR range. So this is for the private A. Since we are creating two, so let's add a new subnet again and just copy the name. Just copy the name. Just put it B there. You can put it in US is to 1B. And just copy this guy as well. So it's we planned that the third octet should be an even number. So we'll put this one here, and we are all good. So this is our private subnet. So we can still go ahead and say, okay, on the same instance as well, we say, okay, let's have our public subnet. So let's change it. Public A. This one A. 10.200.1.0/4. So we got another subnet again. Since we are creating 4 subnets, copy it as well. Public B. So I don't want to start creating, come back again. So that's why it's something I can just create all from here. So EUS1B, can use 1B, and the subnet range is 10.200.3.0/24. How am I getting this IP? We've explained it in our last session. From this guy, we explained it with using the CIDR range. You can see that from this planning, we can just it makes our work very easier. So we'll be able to know, okay, these are my public subnets and these are my private subnets. So we can just easily create them. And there's a URL CIDR.xyz. So you can just put the IP address here. It's 0.0/16. So you can see that this is the /16 subnet. So we now break it down. You can see that we have about 65,000 plus IP. So we can now break it down. Okay, since we have 65,000 available for our VPC to use, so we can now start breaking it down. So let's say each subnet, let's give them the /24. So let's come here and change it. So for example, this guy now, 10.200.1.0. This guy is going to have 256. So, and I explained that in this 256, the first one, this is the first one, is the network address, and the last one is the broadcast address. So, aside from that guy, AWS is going to take 2 IPs as well. So, what you can use in your subnet at the end of the day is like 252 or 253 thereabouts. That's what you can use in your subnet. So, this is just the overview of planning the subnet. So you must be able to plan the subnet very well. So I've seen a scenario where some people go ahead to use a VPC /26. So at the end of the day, when you are not creating the subnet is having like /29. /29, you have less than, is it not 8? Is it not 8 or 6 IPs you can have on /29? Let's try it. 29. Yes, you have 8. And out of these 8, AWS is going to take like 3 or 4 there. So at the end of the day, you just have 4 IPs to use. So that's not a very good planning. So it's very, very important to plan your subnet and your VPC IP address very, very well. So if you don't even have a networking background, all these kind of tools will help you to plan it very well. It's not something very difficult. All these kind of tools, and we have also have IP subnet calculator as well. IP subnet calculator. So you can just put your subnet here, and you put this like the CIDR range here, and everything. So I'm just showing us typical tools that we can use to plan our IP subnet. So now let's go back here. So we have all our 4 subnets here. We have the web app private A, the web app private B, and then we have the web app public A, and we have the web app public B, which is, and another thing I said is that the third update will help you to design it very well. So you'll be able to know, okay, this IPO, is it a public subnet or a private subnet? So for example, now, maybe you implemented like an AWS client VPN, and you are doing it like a trace route, you are troubleshooting. So you want to know, okay, where is this IP address dropping? Is it even dropping on the private subnet or on the public subnet? So those are the things you'll be able to put on your troubleshooting skills together. It's everything still start from design. So let me just create them, and we're good. Okay, I think in that, why this one is doing, I think somebody wants to ask a question.
Yes. Thank you so much. So when I created my VPC, I got 2.
Okay.
So I'm assuming, is it because of the tag?
You got 2 VPC.
Yes. When I
You
create,
know, I told you
after
that there is
creation.
one by default. Do you notice the one
Okay.
by default there? So there is one by default. So, and the default IP is let us just go back. So you can see the default one
Yes.
is this guy. So that one is
Okay.
default. So
Okay.
that's why I said the best thing is just come to this name part and click on the name. So you'll be able to put the default VPC there.
Okay.
So that will help you to identify, okay, this is the default one. So sometimes some people even try to delete this default one. Just delete it. Because you don't have anything to do there, you don't have any VPC there, you don't have any resources there. It's just like the default one by AWS that is there for you. Do you understand? So some people even
Yes.
try to delete it, and they know that, okay, I don't have anything to do with this default
Okay.
VPC again.
Okay. I can understand now. Okay,
Yeah.
thank
So
you.
we have the subnets now. So you can see that this my subnet is the one that has name. All the default one, they don't have name. So one of the things is the default one. I even advise that once you create your VPN, your AWS account, you go to your VPC, delete the default VPC, so that you won't be confused of the VPC or something like that. So you can see that this is our VPC and is associated to our what? This subnet is associated to our VPC. You can all see it here. We have it here already. So now the next thing is our planning. So we need to create Internet Gateway. What does Internet Gateway mean? Internet Gateway is the guy that gives your subnet access to the public. What do I mean by access to the public? It gives them access to the public for inward and outward. I get my point. For example, now from your server, you want to get to the internet, you want to call, maybe you want to download a package or something, you are going to the internet. I get my point. If for example, okay, I host maybe like a shopping app on my app, on an EC2 instance, and I want people to be able to access my application from outside. You know, that's the inward, right? So for both outward and inward from the internet, that internet gateway is going to give you that access. If there is no internet gateway in your VPC, you cannot have internet access. That's the default plan. So the next important thing to do is to create your internet gateway. Our internet gateway is just like a public IP created by AWS for you. You attach it to the VPC, and you can only attach one internet gateway to one VPC. Are you getting my point? So one internet gateway to one VPC. So at the end of the day, you'll be able to have access to the internet. Maybe you create a server here. How do you want to reach it from the internet? You want to SSH to it. If there is no internet gateway there, you cannot, you will not be able to reach it from the internet. So note it very well. So internet gateway gives you access to the internet, but for both inbound and outbound. Now let's create our internet gateway. So there's default one. You know, I told you that default is always there. I intentionally leave it there so that I will be able to explain, okay, maybe if you create an account, this is what you're going to see. So let's create a new one. So let's call it web app IGW. People use IGW, internet gateway. That's all. Yeah, we create it. That's all. It's so very simple. So now the next thing to do, okay, let's attach it to the VPC. So that's the next step to do. So click on actions, attach to VPC. You select your VPC, web app VPC. So this is the corresponding, maybe you want to get the CLI command. This is the corresponding CLI command for it. But we're not using CLI right now. So let's attach internet gateway. So we've attached internet gateway. We've attached internet gateway. Now let me now explain another guy that is very similar to it. Is NAT gateway. So NAT gateway is for let me explain it in this way. You have your database. Your database, you want to access, you want to like download a patch. Maybe you're using Microsoft SQL version something, and you want to upgrade to maybe version 10, and you need to get the new package from outside from the internet, and you're already in a private subnet. So how do you get to internet? So that's where NAT gateway comes in. NAT means network address translation. So how does it work? It just works for your outbound calls. Assuming you are going outside to the internet. Okay, from your database server, you want to get the recent update from the internet from Microsoft's website. So you'll be able to go to the internet. That's what NAT gateway works for. So NAT gateway is attached to your VPC, and it's been referenced for your private subnet only. I get my point. Private subnet are something that you don't want people to access from the internet. So, but in a situation whereby you want to reach internet, you want to download patch, you want to download updates, you want to do some things that you need to get to the internet. So that's where the NAT gateway comes in. So we are going to create it, and I will show you how it works. So now let's create NAT gateway. But before we create a NAT gateway, let me explain something. NAT gateway, there is something we call an elastic IP. Okay, hi John, you have a question.
Yeah. So what is the core difference between NAT gateway and internet gateway?
Okay, so internet gateway works for both outbound and inbound internet calls. You want to go to the internet, it works. You want to we want people from internet to be able to reach you, it works. That's the first difference.
Okay, does it also have NAT in it?
Yeah, it doesn't have, you don't need to know all those NATs something. That NAT part, you are talking as if you're talking in network engineer perspective. AWS has already virtualized, like how do I call it? They've done that kind of mapping internally. So all the internet gateway is just like your passage, just like a gateway to reach the internet. If it is not that was there or part or anything, that's AWS. Nobody will ask you, okay, is it not that it's on internet gateway? Is it parts? Is it anything? But the internet gateway actually, for the difference you need to pick there is that the NAT gateway works for outbound calls to the internet, not for inbound calls. So if you are using a NAT gateway, you can be able to get to the internet. But people from the internet, maybe you are coming from the internet and you want to access it to that server, you can't do that through the NAT gateway. I want you to explain that better.
Yeah. So for users calling a particular machine, right?
Okay.
They will from
Okay.
the outside, they will hit the
Okay.
internet gateway before heading to the respective machine, right?
Exactly.
Okay, so there's more like a translation that is going on in the internet gateway.
Yeah, exactly. So the
Okay.
port address translation, the NAT, and you are talking this because you are a network engineer. So that's why I said don't confuse it. So AWS has already they've made it very clear. So you don't need to worry about maybe it's a port address translation or a NAT address translation. Just know that the internet gateway is your passage to the internet, going up and going forward. But NAT gateway, you will just be able to get to the internet, but anyone in the internet will not be able to get to you. So we'll explain it for that very well now. So NAT gateway is usually attached to the what? It's being referenced, it's being used by the private subnet, because private subnet is where you have your private servers, or you can't just expose your database for people to call it from outside. You can't just do that. Or maybe your Kafka cluster where you have your this thing. So you can't just expose those kind of things to the internet. So you need to find a way to just guide them. So NAT gateway is also even part of like a security guideline when you're working with VPC. So you create the NAT gateway, and there's something here I want us to understand. When you are creating a NAT gateway, one way or the other, still writes under the internet gateway. But don't let me just confuse it. Let me just put it in a way that we'll understand. If you want to create a NAT gateway, you create a NAT gateway in your public subnet. Don't confuse it. You create your NAT gateway in your public subnet. So
I thought it works on. Sorry.
Okay.
I thought the NAT gateway works on the private subnets.
Exactly. Yeah, very good question. What happened is that the private subnet is the one that uses it. I get it. Not private subnet is the one that uses it, but when you want to create it, you create it inside the public subnet, because public subnet is the one that is going outside. I get my point.
Okay.
So it is NAT gateway. That's people really confuse this thing a lot. That's why you need to get it. If you want to create your NAT gateway, you create it in the public subnet. But who is using it? The private subnet is the one using it. So when we get to the route table, you will see the difference. So
great.
So it creates. So I can click either of the public subnet I want. Just put it in the public subnet. So the public subnet. So there's something elastic. So you can see the connectivity public. So there's something called elastic IP. Elastic IP is an IP. For example, now let me give you an example now. Most of us work in an organization. When you log in the morning, you connect to your wireless. It gives you an IP, right? Which is fine. So when you're going in the night, maybe the IP is not statically bound to you. Maybe when you're coming in the next week, or you don't even come to the office maybe after a week, or once you close your laptop, it's the next day you are coming in, you might get a new IP. So this is where the elastic IP comes in. Elastic IP means just like a static public IP we are attaching to the NAT gateway. Just like something, okay, this public IP is for NAT gateway only. So nobody is taking it with him. So anytime, any day, this public IP is for the NAT gateway. So we need to allocate it an elastic IP. So once you click on allocate, that's automatically allocated. You can see this IP 18.213.212.107. This is a public IP. So if you attach it to a subnet, and that's all. You've created your NAT gateway. And this NAT gateway part might seem very, very something, but this is you need to just understand it basically like the way we are starting it now, because when we are going forward, not to make things complicated. So let me know if you understand before I move to the route table.
So can you please shed more light on why it is configured on the public and not on private?
Thank you very much. So the reason why it is configured on the public is that the guy still reference the public route table to go out. It's just like, okay, maybe you want to see John, you need to come and meet me first. Maybe John, maybe for example now, like you want to send a letter. You want to send a letter. Maybe you are in village A, you are in village A, I'm in village B. Village B is the one closest to the posting service. So it's just if you from village A coming from the private subnet, once you get to village B is still the public route table, which is the public route table that you use as a next up to the internet. I get my point.
Okay.
So if I'm sending data now, if I'm sending something from my private subnet, I will say that, okay, NAT gateway, I'm going to the internet. Okay, please take me to the internet. So the NAT gateway now looks like, okay, we are going to the internet. But I'm just a NAT gateway. So the best thing I can do for you is for me to take you to the internet gateway. And where is the internet gateway? The internet gateway is on the public subnet. I getting it.
Okay, cool.
So from your server, the server say, okay, I'm going to the internet. Okay, right, that's fine. Okay, how do I go to the internet? Okay, the NAT gateway, AWS has done that kind of internal NATing. There's maybe after we finish that, I think the test on it. It's a very high level virtualized design that was done in terms of NATing and all of that internally. So someone that is not a network engineer might get it confused, but I'm just trying to put it in a way that will understand at a very low level something. So the NAT, the private subnets, if they want to go to the internet, if they want to go to the internet, their NAT, their gateway is the NAT gateway. But internally, the NAT gateway still depends on the public route table, which is the internet gateway to go to the internet. So that's how it works. So now let's go to the route table. So this is the default route table. Now let's create our route table. So we are going to have two route tables here. We're going to have the public route table. We're going to have the private route table. Web app public. RT. I use public RT. Route table is RT. So you click on your VPC, and that's all for now. That's all for now. That is not all, but that's all for now. So the next thing you will do now, associate your subnets. So the subnets that's why I said that the issue of private public subnets is based on your own design. You are the one that you design it. It's from your route table that you will design. Okay, this guy is the public subnet, this guy is the private subnet. So the next thing you now associate your public subnet to the public route table. Edit association. You then click on it from 1, 2, and you associate, save association. I get my point. So automatically you've seen that I've associated the public route table to it, the public subnet to the public route table. So what's the next thing? The next thing is, and another thing, your route table, it has a default route for your local. It means that this guy can reach any guy in the subnet. It's like a local. You know, this is our VPC side range. So any guy in this subnet, this guy, it shows that the target is within the VPC. It's local to me. It's within my VPC. So edit route. You now add a route. Are you getting the way I'm doing it? Let me go back again. It's a public route table. You click on it. You click on routes and click on edit route. So you now add a route. The add a route means that you want to go to the internet. And the default internet route is 0.0.0, which means anybody on the internet. So you click on default route and you check, okay, on your public sub route table, who is going to take you to the internet? Is your internet gateway, right? Are we all there?
Yes.
So you click on your internet gateway
Yeah.
and you choose your internet gateway, web app, IP job, and you save your changes as well. So it shows that okay, all my subnets in this VPC, anyone going to the internet among all of them should pass through the internet gateway to go to the internet. This is what the routing means. So we are through with the public route table.
Okay.
Now let's go to the private route table. Yeah, I'm with you.
Yeah. So before the subnet association, all the machines in the public subnets, they will be able to interact, they can ping each other, right?
Yes.
But then but then they won't be able to reach the private subnet. Is that correct?
Private subnet as well?
So you have public subnets, you have private subnets in the VPC.
Yeah, you are default. All of them will be able to read themselves by default.
By default, okay, good.
Yes, all of it. You know, it is because the local there is a local route on the guide that points to the all VPC CIDR range that points to local. It shows that all of them will be able to read themselves by default.
Okay. In as much as they are within the same VPC.
Exactly. So it is now taking it a step further. Maybe if they are going to the internet, that's when the scenario of the NAT gateway, the internet gateway comes in, and we can still do like a kind of segregation based on subnet level. That's where the network address access control list comes in. So the network access control list we can segregate based on subnet. We'll still get there.
Okay. So that's the network access control is used to control the communication of one subnet to the other.
Exactly.
All right. Continue. Thank you.
You're welcome. So let's get the second guide: web app private RT. So we click the VPC. You can see that you need to associate it with the VPC. So route table, you need to associate it with the VPC. So you create the route table. And after that guy, you associate your subnets. So you can see that you're not breaking it down by yourself now. That's why I said Terraform is easy. All this clicking. But I really like that we're able to go through it together like this and understand it very well. So you can see that we've associated the private subnets there. So this route table is just like a directory. Okay, any server in this private subnet will just check. Okay, I'm going to the internet. Okay, who should I go and meet that will take me to the internet? Okay, go and meet NAT gateway. So NAT gateway will now take him, passing him through the internet gateway to go to internet. So now let's do the route. So we edit the route. We add. There's a lot of things we can still do. I'm still planning that we're going to do VPN. We're going to do transit gateway. We're still going to have a lot of things, VPC endpoint and some of that. There's a lot of interesting things to be done here.
You must
so you click on internet gateway. You click on NAT gateway, and so this default route goes through the NAT gateway. So if you can see, when you're adding a route, you will see a lot of options. When you're adding a route, you see internet gateway. Let's go back. You see internet gateway, you see instance, gateway, load balancer. All these guys have their own implementation. You will see peering, you see network interface. All these guys, they have their own meaning. And it's going to be very interesting when we move forward.
Yeah, sorry, Sulaiman. Sorry.
Yeah.
If you want to route to another VPC, is it this place we do it also?
Yeah, yes. It's this way as well. It's this route table we do it. Okay. But don't let us get to that stage now. So now let's
not complicate it. Let's take it small.
Yeah. Let's take it small. So we are all done. Now let's go back to our task. I think these are our tasks. I think so this database VPC and backend VPC, you are doing that. I'm not going to do that. So I think we've done this private subnet. So this is typically what we've done today. This is typically what we've done today. The public subnet, private subnet. The availability zone, I explained availability zone is just like a different data center inside your region. So you might have a big region, is just like a geographical location when you have the AWS presence there. And availability zone is just like something like an highly available system. So in a region, we have more than 2 availability zones. That's why you can see that in this US East one, you have 6 availability zone. So now let's go to this guy. We've done this guy, interesting. We've done this guy, interesting. Now let's go to the. Let me go to this guy yet. Let me go to this guy and explain this guy. So I want us to understand this thing very well. Now that comes to the question: what is the difference between network ACL and security group? You can see this guy. Let me just board it very well. You can see this security group here is attached to your server. So it works on an instance level, while the network ACL works on the subnet level. I get my point. So I'm talking about your security now. Your security group will work only on the instance level, on the server level. Why this guy, network ACL, works on the subnet level? What does it mean? It means that this server, it works on the server level. Maybe you want to expose, maybe for example, now you are running a Java application, port 8080, right? This port 8080. So you have customers, maybe something. Let's say, should we use 8080? Let's use 443. It's 443. So you have your server running, maybe your application on this server. This is a server here on 443. So what this guy is going to do is going to allow, okay, this is a web server from the internet. So anybody coming from 0.0.0 should be able to access this guy on that port. You can see that the flow is inbound, right? So this guy only does for inbound calls. That's why they call it a stateful protection. So is any guy coming to the server, that's what the security group works on. So you just check, okay, you are 0.0.0. 0.0.0 means that any guy coming from the internet. So you're coming from the internet, okay, good. When you get here, it checks, okay, on my security group, do I have a rule that says anybody should be able to access this guy on port 443? So if there is, I'll be able to enter. Same thing, this is my Bastion server, my jump server. I want to access it, maybe RDP, which is port 3389, or SSH port 22. I want to access it from the internet. So when I get here, the security group will check, okay, you're coming from the internet, right? Okay, that's fine. Okay, do I have a rule that supports this guy? But take note of something. This guy only have allow, doesn't have deny. It only has allow. There is no deny. So there is no deny rule in security group. You just only allow the IP and the ports. And it is stateful. Stateful means that it's when you are coming in.
Yeah, so
just for inbound. Yeah, I'm with you.
So does that mean that the SG has implicit deny all or deny any?
No. It doesn't have any. It's going to. Yes. Let me come into that. So it has like an implicit deny by default for the inbound. Implicit deny, but you won't see the deny there because the way it works only on allow mode. So if you don't specify the port, you need to whitelist what you want to access. So if you don't whitelist it, by default, it's going to deny them. But you won't see maybe a deny rule on the security group. But that's what it's doing. It's just protecting on the server level. And it's the stateful means that, okay, when you are coming in, when you hit the guy, if you are going out, you are free to go. Just like maybe you want to enter your house, you need to open your door and come in. If you are going out, you can just go out any way you like. So that's why they said it's stateful. So it's just allowed your presence to the guy, to the server. Going out, anybody can go out, my guy. Just go out. But if you want to come in, you need to say, okay, I'm coming with this IP and I'm coming to this port. That's it for security group. For network ACL, it works on the subnet level. So it means that anybody coming in, you must give them, you're not giving them based on portal. You must give them access coming in and going out. That's why they called network ACL is stateless. It doesn't know you. It doesn't know you. Something like an airport. You're coming in, you show your password, you're going out, you show. So there is no how you do. We just say, okay, I'm in, and when I'm going out, no. Once you are coming in, it's going to check you. When you are going out, it's going to check you again. That's network ACL. So it is stateless and it only works on subnet level. You attach your subnet to it. Maybe you want all your public subnet to have a particular public network access control list. You attach them to that control list. We're going to do that. Are you getting my point? Am I communicating? Is it clear? That's why I just take time to draw this so that we'll understand it very well. So these two guys are one of the important measures for you in your subnet, in your VPC. These two guys are very, very important. Before we start going to the network firewalls and all of that, all those ones who works on based on layer 7 and all of that. But let's see layer 3. We have the OSI model, right? The layer 3, which is the network layer, and the TCP layer, which is the transport layer. These two guys are very, very important. These two guys are very, very important. You can't just go and create a security group that people should have access to your database like that. Something is going to share your casala with Boston. Sure, you get. So those are the things you just need to note when you are creating security group. So let's go back. So this is our VPC. So now let's create our net security group. So security group, you create it based on the server you want to. So for me, I personally like creating my security group before even creating my server. So these are the existing security group that we have. So let's create a new one. So we have a Bastion host. A Bastion host is a host that people, just like your jump server in your company, if you want to go to your production network, you need like a guy, a middleman that you will log into. And from that guy, you'll be able to access your servers. So just let's call it Bastion SG. Security group means SG. So this guy is maybe it's a Windows server or a Linux server that you want to access from the internet. So that guy, you can access it from the internet automatically in your security group. What needs to be in your security group? This guy, is it fine like this, or I need to change it? Hello, can anyone hear me?
Yeah, hello. We have to change
Yeah,
it.
it's okay like that.
We can hear you.
It's not okay. It's not okay. It's not okay.
It's not okay.
It's not okay. It's
Change
not
it
okay.
before the VPC.
Exactly. So security groups works based on VPC. That's another thing. This is the reason why I asked the question. So you attach your security group to your VPC. So you just come here and click down Web App VPC. So you can see that the outbound by default, it is implicit allow anybody going out. It's a free ride. So it is the inbound that you need to now specify, okay, anybody coming from the internet, okay, I want SSH anywhere, IPv4. So you now put it SSH access for Linux jump servers. You attach and add another one, RDP. It came here, it just come here, RDP. Maybe it's a Windows. You can just use the same security group for your Windows, Bastion host, or anyone. So anyway, anybody come from. So this one is RDP access for Windows Windows jump servers. So and then you
Hello,
create
Sulaiman.
it. Yeah, I joined.
Are you still going to spin up a Linux or Windows servers just to test?
Yes, I will do that. SSH.
Okay,
So you
thank
need to
you.
put description and because of time, I think we are already getting to like
Yeah,
1.5
time
hour.
has gone naturally.
So so let me just create this guy. So you can see that I've created my Bastion. So either I create a security group. So what I need to now associate it to the EC2 instance. But let me hold on. Let's quickly go to the network ACL. So network ACL. So let's create a network ACL. There is default one there. Don't worry, these are the default one. If you see the VPC, they are attached to. Yeah. When we are creating our VPC, we also have when we are creating our VPC, it comes with network ACL. So that's why you need to check here. So now let's click on this guy. Let's click on the inbound. You can see this guy allow anything. This is the last one, which is deny. So this guy works on rule number 1, rule number 2, rule number 3. If any of the rule doesn't match, it goes off. I get it. So we can now create 2. We can now create 2. So we can create 2, or we can even delete this guy. Let's delete this guy. Let's delete this guy. I don't want it to send I don't want it to okay, it's attached to a VPC. I need to detach it first or something. Or let's manage it. Let's manage it. I'm coming. Let's call it public web app public. That's why I like Terraform public ACL. Let me see. So you can see this guy. Maybe when I was creating my VPC, again, I said the guy should create it for me. So you can see that this guy allow anything coming in, that's the inbound, and also the outbound as well. You need to specify as well, allow anything going out as well. So the network ACL works for both inbound and outbound. So this is what I want to specify. Another thing is the subnet association. You can see that the 4 subnets are specified here. So maybe I don't want everybody from the internet to access my private subnet, so I can just edit this guy. Just click on, let me just straight here. So okay. This is the default network ACL. Okay, I think we can't edit it here. So I think we need to edit it from somewhere else. I'm coming. Edit subnet association. So edit the subnet association from the network itself. Okay, I'm coming. That's why I should have deleted this guy from the onset. This the default one, so it comes when we are creating the VPC. It's a blow. sorry, you are getting there. But what I actually want to show, that's only just pressure things very much. So maybe we'll continue from here from next week. But what I want to show you is that you can see the network ACL. So this is what I want to show you, that this guy, you need to explicitly allow it from inbound and outbound. So maybe you want to edit as well. Maybe I want to edit something. I can come here, add a new rule, maybe 101. Okay, I want anybody coming from the internet. Okay, I want something like SSH from anybody coming from the internet to allow, and I save it. But this is just like a repetition because this first rule has allowed everything coming in. Do you get my point? So you can just save changes and all. So this is how a network ACL actually works. So for the editing part, maybe we'll continue next week. But before that, let's just quickly create a server and EC2 instance and we'll be able to call it a day. Oh, I know it's much a bit, but I know it's something that will. So let's create a server in a public subnet. I don't know. This guy is a little bit slow. So let's launch a task. Let's launch an EC2 instance. I think we did. So all this is what we all did with Terraform last week. So let's call it our Bastion hosts or jump server. Bastion hosts.
Let's Kukuma Terraform it, man.
But we need to. You can't
Yo.
use Terraform.
Please don't Terraform today yet.
Don't Terraform anything. No.
Don't
Don't
Terraform yet.
Terraform anything. No.
Let's click on. So let's choose Ubuntu.
Okay, thank
so we
you.
can just use any Ubuntu. I don't know. This is very slow somehow, but I think we'll get there. So let's just So you can see I've created an EC2 instance. I've chosen Ubuntu, Ubuntu 24 LTS. You can choose Amazon image. You can use Red Hat, SUSE, Debian, and all of that. So assuming it's a Windows server, just Windows, and we are good. So we just come here and choose the instance type. Your security key. If you remember, is continuum. The one you create. I think we did that one last session. How to create a key pair. So you can now edit. You choose your VPC. So it's a public something. So I can choose any of the instance, but this is a jump server. I want to access it from the internet. So let me just put it on public A or public B. Anyone works. So you want to assign a public IP. So this means that maybe you want to auto assign a public IP. Is enabled. So it's going to assign a public IP to this guy. But when you're creating a private, maybe your database or something that you don't want them to access from the internet, you don't auto assign a public IP. You disable it. Something that you don't want them to have access to the internet. So you don't even give them public IP from the beginning at all. So but this guy, I want this guy to have a public IP. So that's why I enable. So we've already created an existing security group. So just come here. You can see Bastion here is here. And we have it here already. And we are good. So let's create and we launch. So let me click on bash. Bash. I want to see if I can access this guy. So let's go to the instance. See. And the guy is creating and is initializing. So you can just wait for a while. I think the guy is running. So this is an instance now. You can see that this guy, we've created this guy. So let's go to the networking. Is it my network is slow or this thing is just slow, a little bit slow?
No, it takes time
Let's try again.
sometimes.
So now you can see that this guy, it has assigned the public IP to it. And you can see the public IP. So once you see this IP, 10.201.38, you know that, okay, this third octet, so this shows that this server is in my public subnet. But assuming you see 10.202. something, you know that, okay, this server is in my private subnet. Especially if you are working with VPC flow logs, you need to be able to identify your IP and all of that. So that's why when you add, one of the important things is that design. So you need to know, okay, how many private subnets am I having? How many public subnets am I using? So you can see the server is running, and this is the VPC, this is subnets, this is subnet, and all of that. And this is the key pair is the pen file I'm using to authenticate. From here on the networking, you can have all these guys here. So now let's go. Let's go. So cd documents. That's the folder where I have my pen key. SSH-I. Let's continue. I'm not sure it's here. Let me go back to downloads. So if you are starting, you might need to learn a little bit of Linux. So you need it. CD. So let's say SSH-I as continuum. I'm just
No, no, I
referencing
don't
my
think you
key
are
file.
I don't think you are sharing that screen.
Oh yeah, I'm not sharing that guy. Okay. Oh, I'm coming. I will do that.
Okay.
Thank you very much. Okay, so I think this guy is running now. Let's just refresh. I don't want this video to be up to 2 hours. it's a bit much. So I think the guy is still initializing. I don't know why the guy is still takes a long time like this. But let's just wait for a while. So this status check needs to be 2/2, which means that the status check is fine. So let me just copy the public IP because that's what I can reach from the internet. So let me copy it and my sharing. Let me now share this guy. Okay, let's even see. Okay, let's. One of the things to say is that port checker.
Are
Let's
you
do port
trying
checker
to
this IO.
SSH through a terminal?
Yes, I will do that. But I just want to show you something.
Okay.
Paste this public IP, put port 22 there. You see that it's going to be. Why is it not coming? Maybe the server is not yet up. Let me see the public IP that I copied. Okay, let me copy it. Why? Maybe because the server is not yet up. That's why. So ideally, well, the reason why I'm showing that is that you can see that the port 22 is allowed from anybody from outside. So anybody can be able to, as far as you have your pen file, you'll be able to log into the server. So this is just the first stage. So maybe you now have your public IP. Okay, maybe you are coming in from your company environment, from your production company environment, that you have a specific public IP. So you can put that inside your security group. Instead of putting any, you just put your selected public IP and you put it there and everything is fine. Or assuming you are coming from your VPN and all of that. But next session, we'll be able to go through over that one very, very well. Let's do status check finish so that I think it's finished now. So that let's see. Let's check now. Why? I don't know why it's not. Well, let's see if you can tell SSH. Let me share my let me share my listing. Let me share my Bash terminal. I don't want to share my entire screen. That's why. I think I don't have a choice at this time. I need to. So let me know once you can see my screen. So this is where I have my this thing. So I'm just say
Is this Git Bash?
yes, or you can use any terminal you feel like.
Okay.
Let's continue. Ubuntu at put the public IP there. And you enter. So yes. So you should be able to enter now. So inside the server. So IP ADDR. You see that it's IP ADDR. You can see this is the IP address of the server. Sudo apt update. So I can get to the internet. I can go to the internet, come back, and all of that. Yeah. Go to
Also,
the internet,
can we check the flow log? What is saying?
Yeah, you need to enable the flow log. I need to enable it, and time is already going on my side here. So let's ping Google. Maybe next week we can. And now we're going to start from flow log.
Thank you so much.
So ping, you can see ping is going. So I'm able to get to the internet. So assuming, so this guy means that, okay, this guy can reach internet, can get anywhere. Maybe, I don't know, it's Facebook IP. Can you ping Facebook IP? Let me see. Yeah, I can ping Facebook. So I can reach anybody on the internet and all of that, and I'm fine. So this shows that this Bastion Host can access anything on the internet. So what we'll be starting next week is that, okay, we'll be having some servers on our private subnets, and we'll now start putting restrictions. Okay, I only want something, maybe something from my public subnet to only reach my private subnet servers, or NAT gateway and all of that. So those are the things I will try to do in the next class. And also we're going to inspect our flow logs, so we'll be able to see. So flow logs, you can do it on two sides. You can do it on your VPC. You can do it on your VPC, you can do it on your subnet, and you can also do it on the instance level, which is the ENI. So those are the three ways you can do your flow logs, but it's advisable to do it on the VPC or on the subnet. You know, doing it on the VPC, we capture all traffic on your VPC. Doing it on the subnet to capture all the traffic in your subnet, and doing it on the ENI, which is the NIC interface, the network interface card, we only capture the traffic on that server. So those are the three ways to do it. So with the use of VPC CloudWatch, VPC Flow Logs, and CloudWatch, because we need to create a group and all of that. And we can even do a query. You can run some SQL to check and all of that. So we'll do that one next week, and we'll try to see some private communication and how you can use security group to redefine your communication. And probably we can even do VPC peering. That's when you guys have created your VPC. You need to create the 3 VPC so that we'll be able to do VPC peering by next week. I think, is that fine? So thank you everyone for joining to this class, and
Thank you
I think
so much.
it's a really it's a long time, but at least it was interesting. So thank you very much, and
Thank you so much for everything.
so